In this example, I need to solve 4x squared plus 27x equals 7. Well, what type of equation do I have here? Well, I have an x squared term here, and here I have an x, and remember there's a 1 on that, so it's degree 1. So what's the highest exponent on any of my x's? It's a 2. So I have a quadratic equation. And what's the first thing we like to do when solving quadratic equations? We want to see if it factors. So let's look at the steps in solving a quadratic equation by factoring. We need to write it in standard form. That means I need everything on one side in descending order and 0 on the other. Is that what I have in my situation here? No, unfortunately, I have the 7 that's on the right-hand side. So I'm going to have to subtract 7 from both sides of my equation. And when I do that, on the right-hand side, I get 7 minus 7 is 0. That's what I wanted on the right-hand side. And on the left-hand side, these are all unlike terms, so I need to write them in descending order. So I'm going to have 4x squared, next is plus 27x minus 7. So I've now done step 1. It's in standard form. Now I need to factor. The first thing we try and do with every factoring problem is there a greatest common factor? Well, my numbers are 4, 27, and negative 7. No numerical common factor. They don't all have x's, so I have no common factors. So now I'm going to compare this to ax squared plus bx plus c. A is the coefficient of the x squared term, so it's 4. B is the coefficient of the x, which is 27. And c is the constant of negative 7. So I'm going to multiply a times c. So it's 4 times negative 7, which is negative 28. So I'm looking for two numbers that multiply to AC, which is negative 28, and add to B, which is positive 27. Since my two numbers multiply to a negative, they have to be opposite in sign. And if they add to a positive, the one with the bigger absolute value has to be positive. So I'm going to start with negative 1 and positive 28. Those multiply to negative 28. And negative 1 plus 28, oh, that's nice. The very first one I try adds to 27. So that is the number I'm looking for. So these are not my factors. That's what I'm going to break my middle term down into. So instead of 27x, I'm going to write negative 1x, or just negative x plus 28x. So I'm going to rewrite my equation as 4x squared minus x plus 28x. Remember, I've just rewritten that middle term, 27x, as negative x plus 28x. Then finally, my constant minus 7 equals 0. The reason we do this is now we have 4 terms. We factor by grouping. What do the first two have in common? Just an x. And so I pull an x out of 4x squared. It's going to leave 4x. Pull an x out of a negative x. Be careful. It leaves something, a placeholder, and in this case, it's going to be negative 1. Because remember, x times negative 1 is negative x. Now, always in factoring by grouping, bring down the middle sign. And what do the last two have in common? I think the only thing they have in common is a 7. And I pull a 7 out of a 28x. It's going to leave 4x. Pull a 7 out of a negative 7. It's going to leave negative 1. So now, is this binomial the same as this? Yes. So that is my common binomial factor that I factor in front. So I have 4x minus 1 is my common binomial factor. And what does it leave to put in the second parentheses? X plus 7. So I have my two factors equaling 0. So I factored it. Now we set each factor equal to 0. So I have 4x minus 1 equals 0 and x plus 7 equals 0. So now last thing, solve each equation. So I'm going to add 1 to both sides. So I get 4x equals positive 1. Divide both sides by 4. I get x equals 1/4. That is my first solution. The second one comes from x plus 7 equals 0. Subtract 7 from both sides. I get x equals negative 7. So there are my two solutions to this quadratic equation. If you wanted to check it, you'd take each solution in turn, plug it into the original equation to see if I get a true statement. You'd have to check x equals 1/4 and x equals negative 7.